All right, let's factor this polynomial, and we're going to use something called grouping. We're going to factor by grouping. And what you do is you group the two sections. So you group this section of two pieces, and you pull out the GCF. So if you look at these two, hopefully you notice you can pull out a 4x squared out of these two. Out of these two, hopefully you notice you can pull out a negative 9. Well, negative 9 goes in both those. So when you pull your 4x squared out of these two, you're left with x, because 4x squared times x is 4x cubed. 4x squared times negative 2 is negative 8x squared. And then here, when you pull out the negative 9 out of both of these two, negative 9 times x is negative 9x. Negative 9 times negative 2 is positive 18. So again, when you pull out the GCFs, and what your goal is, when you do that, is these two pieces you hope are going to be identical. If they are identical, you can factor by grouping. If these two are not identical, you could not, or maybe you didn't pull out the best GCF or best common factor to do that. Now, once I pulled out the 4x squared and the negative 9x, those two can group together, and these are the same. So basically, these two pieces group together, getting 4x squared minus 9 and the x minus 2. This right here has been factored by grouping. Now the problem is, some of you might say, I'm done. You did factor by grouping, but you can still factor this. This right here is a difference of squares. If you notice, this right here is 2x squared, or 2x times 2x. This is 3 times 3. It's called a difference of squares. So you have 2x minus 3, 2x plus 3. It's called a difference of squares. And you still have your x minus 2. So this is completely factored. Again, this is factoring by grouping. Again, look at the groups, pull out a GCF, and then what's left has to be the same to use this method. Now a lot of times you might want to pull out, if you see negative here, a lot of times you want this to be a negative. That's pretty important to observe and think about. Now for this one right here, this is not by grouping because this is not a 4 terms. You have to have 4 terms to do by grouping. This right here is a simple diamond. It just has a 4th power and an x squared. So don't be scared. Basically you just put this number on top, this number on bottom, like a normal diamond problem. So what two numbers multiply to get negative 75 and add to get negative 22? Well, it's negative 25 and 3. And then you put it simply like this, except usually, didn't you always have x's and x's? But since it's x to the 4th, you have x squared and x squared. Again, instead of putting x and x, you have x squared and x squared because that's an x to the 4th and an x squared here. So that's basically the only difference. It's like a normal diamond factoring, except again, since you have x squared and x to the 4th and x squared, you have an x squared in both spots. Then sometimes, so this is done factoring that method, then you got to look at each piece and see if each piece could be factored. In this situation, here is a difference of squares. This right here is a difference of squares. This is x squared, this is 5 squared. So it's x minus 5, x plus 5, and then this piece, x squared plus 3. So make sure you factor completely. This here is grouping. This here is just a diamond method, but it's a little weird looking. And be careful that you factor the leftovers. Sometimes a piece of it could still be factored. Sometimes the pieces cannot be factored.